discuss this very important result. That is mean value theorem for a scalar field. Mean value theorem for a real valued function already we have seen in 12th standard also and in FY/BSc also. 3 mean value theorems we have already discussed. Okay, but this is a mean value theorem for a scalar field. So let us start discuss the proof of this theorem. What we have a set S. We have a set S which is subset of Rn. Okay, and suppose this is a real line. So f is a function from S to R. So we call it as a scalar field, right? And some point we have A, and we have a vector u bar. So you know that easily we can find directional derivative. Since we have a point, we have a vector, okay, so we can find directional derivative. So if such directional derivative exists, then we have to prove this equality. So we have to focus on this equality. What we have to prove? F of a plus u minus f of a is equal to directional derivative of f at a plus theta u in direction of u. What is theta? Theta is any real number which lies between open interval 0, 1. So we have to prove it. See, a proof is little bit constructive. Constructive, that means we have to define some functions on our own, and with the help of them we have to prove this theorem. So let us start to do. So I am going to define here, let G defined from close interval 0, 1 to R, I will mention be defined as, see, it is defined as G of t is equal to f of a plus tu. In this way we have defined this function. See, our first task is to prove that this function which I defined is differentiable. So now we will prove that, I will mention now we will prove that G is differentiable on closed interval 0, 1. With the help of simply definition we are going to prove it, but we don't have no space here. So make a screenshot of it. After that we will go further. So let us find directional derivative with the help of definition. What is definition of g dash of t? Limit h tends to 0 g of t plus h minus g of t divided by h. So this is a basic definition, okay, of derivative. This is equal to, see, what is g of t? I will mention here, this is f of a plus tu. Okay, so this is in this way we have defined this function g. So therefore limit h tends to 0 at a place of t. We have to put t plus h. So it will be f of a plus t plus h u minus g of t means simply this one, f of a plus tu divided by h. Okay, so this is equal to limit h tends to 0 f of, I will multiply a plus tu plus hu minus f of a plus tu divided by h. See, this is nothing but definition of directional derivative, right? So if you call it as b, a plus tu is equal to, if you call it as b, we will have f of b plus hu minus f of b divided by h. So this is definition of directional derivative. So that's why we can write this is du f of a plus tu. So this is simply directional derivative of f, okay, at a plus tu in the direction of u we have got. So therefore I will clearly mention. So therefore what we have? Therefore g dash of t is equal to du f of a plus t. Okay, so this thing we have. See, that means basically derivative exists. That is a very important thing we have got. So therefore I will declare, therefore g is differentiable on closed interval 0, 1, and we have got its derivative. Do you know one result? Every differentiable function is continuous. So therefore what can we write? Therefore g is continuous on closed interval 0, 1. So what we have got? We have G is continuous as well as G is differentiable. Do you remember anything? So these are basic conditions of mean value theorem which we have studied in 12th standard. Okay, we call it as a Lagrange's mean value theorem. So therefore I can write, therefore by Lagrange's mean value theorem, what can we write? So we don't have a space, make a screenshot of it. After that we will go further. Please make a screenshot of it. See, Lagrange's mean value theorem says there exists theta belongs to open interval 0, 1 such that, okay, I will tell you first what is a statement of Lagrange's mean value theorem, then we can easily write it. Theorem says if you have a function f from closed interval a b to r, suppose we have a function like this, and f is continuous on closed interval a b, f is differentiable on open interval a b, then there exists theta belongs to open interval a b such that f dash of theta is equal to f of b minus f of a divided by b minus a. Okay, so this is the statement of Lagrange's mean value theorem. So I am going to use it, but instead of closed interval a b, what we have? Closed interval 0, 1. So let us use, so therefore such that g dash of theta is equal to, what can I write? G of, see, a means 0 and b means 1, we have g of 1 minus g of 0 upon b minus a, that means 1 minus 0. So therefore g dash of theta is equal to g of 1. So what is the definition of g of t? I will write here, f of a plus tu. In this way we have defined g, right? So g of 1, that means if I put t is equal to 1, we will have f of a plus u, since I am putting t is equal to 1, minus g of 0, that means we have to put t is equal to 0, so we will have f of a. Okay. And what is g dash of theta? G dash of t we have got here, getting. So instead of t, if I put theta there, we will have du f of a plus theta u is equal to f of a plus u minus f of a. So this is directional derivative of f at a plus theta u we have got. Okay, so we have proved it here. Okay, so just let me remove it. After that you can make a screenshot of it, the final proof. Okay, so this is, you have already taken screenshot of this part, so I am removing it. So you will simply get just simply proof. Okay, so now you can make a screenshot of this part. Thank you. Bye bye.